we are making robots, but we humans are still having issues with how to use microphones. So that's great. Great. Thanks a lot for being here and participating in the ROS-I APAC Summit. I think we have a really great robotics community here in Singapore. A lot of faces that I already know, a lot of new faces as well. So I hope I can share some of the stuff that we've been doing at KABAM. This is not a sales pitch. So if it was, I wouldn't be here, thankfully. I'm not a good salesperson because I actually don't like using the term AI. So I tried as much as I could to remove, but I think there's still some in there. But maybe we can catch over a tea break or something, and you can tell me how we have to address this proliferation of the use of the term AI, because I have some thoughts about that. All right, so that's why I just made it intelligence, not artificial intelligence. So what I wanted to share with you here today is how KABAM is using these three pillars: robotics, intelligence, and connectivity, to help reform how physical security is imagined. For those of you who don't know what physical security means, physical security is basically things that you would do in a building or a outdoor space or whatever it is to make sure that your assets are protected, right? So this is done by CCTV cameras, security guards, and any other things that you would do to protect your assets against harm or other things that could happen. Okay, so that's what I will be talking about here today. So the evolution of physical security has been through a bunch of different things. I myself am new to the concept of physical security. I've been doing robots for a while, but physical security is something new to me. But like with most robotics value, where this is helping here is to address the labor crunch. So I think we saw a couple of people talk about that already in the morning. So we know that trying to automate some of these tasks for these specific industries is quite useful for us, both as a ecosystem as well as the economy itself. So what's happening here? There are a few interesting numbers here. The average age of a security officer is 54 years old, quite close to being retired. Actually, it's a bit lower than cleaners. Cleaners is much worse, which is why you see so many cleaning robots out there right now and becoming more and more commoditized. What is scary, at least to me, is by 2030, in 3 of the most economically friendly countries in the world, Singapore, Japan, and Germany, it's going to be close to 1 in 4 and 1 in 3. So that's quite scary to me. So we need to figure out a way in which to enable these people to still do their jobs, and also find a way to encourage younger people to take in these kinds of jobs as well. So that's where we think robots and new age technology can help, is not only to help the existing workforce, which is becoming older, but also to attract new talent. So because now they would think that this is not your traditional roles, this is more high level roles, which has emotional intelligence involved, it has other technology involved that you need to be managing as well. So it's not considered with the traditional stereotypes of being a hard job that pays low wages. So we are trying to basically redefine what these roles mean as well as we move along. So how has physical security transformed over the past years? So this is a fairly simple slide where it started off with basically security guards. You would have security guards with sticks going around and then doing security. Then we knew that security guards cannot be at all places at all times 24/7, not sleeping. So we needed something like CCTV cameras. So CCTV cameras came in, and now we have CCTV cameras all over built environments, giving you a good overview of what's happening. But there was an addition to this CCTV cameras, which is the video analytics part. So previously, even though you install CCTV cameras, you had human persons sitting in front of a monitor looking at 24 CCTV cameras all the time. It's actually it's better to go for a walk rather than do that, actually, if you ask me. So then you had the concept of video analytics, which was using traditional computer vision and other machine learning models to detect certain kind of activities. So it became a detection-based activity. So instead of looking at my 4x4 CCTV camera panel, now I can wait for some alert to come in and then do something, right? But with CCTV cameras also come certain disadvantages in that they are usually hidden, mounted somewhere, and people have gotten so used to it that sometimes the deterrence is not there. So people are looking to robots to provide physical deterrence. So some of our customers actually say, even if your robot does not do anything, as long as it's roaming around, I'm actually okay with that as well. So that's a very, very low-hanging fruit, by the way, but if we can still do that, then that's good. Additionally, now that you have a human perspective in terms of the field of view, what it can see, usually CCTV cameras are mounted on a fixed location, and a lot of the video analytics algorithms are trained for that field of view, not for a person field of view as well. So when you start putting in some of these algorithms inside the robots, you need to retrain them and retune them as well. And then future directions is to see how, with the advent of new technology, how can we make the robots and other technology intersect to provide a more security guard-like function that can be automated more. So I'll be talking about that in a little bit as well. So why are security robots important? I talked about this a little bit, but dive in a little bit deeper. The first thing is vigilance and alertness. Hopefully the robots don't get tired. The only thing they need to stop for is batteries. But now we are also looking at things like swappable batteries and things like that. So a particular robot does not need to be at a charging dock for a long time. You can easily swap out batteries and stuff like that as well. Enhanced sensing and threat detection. So this is where video analytics comes in. In addition to camera-based analytics, we are also looking into other types of sensors like thermal imaging, even for chemical spill detection and stuff like that for specific use cases. Two-way communication. A camera is usually mounted somewhere in the ceiling, so if somebody wants help, they can't really ask for it. But if they see a robot moving around and there's a big call security button, they can press that and then ask for help as well. So this gives a more collaborative framework and about putting human in the center of the design of operations as well. Real-time data reporting, we found this the hard way. We thought having a robot that does the best detections and best navigation would solve security. But ultimately, the end users want proper reporting of how much the robot has worked, how many patrols has it done, how many detections has it done, because they want to be able to calculate some kind of ROI, and also to their end users, because the kind of people that we deal with are security agencies who fight for tenders for another end user. So we don't directly talk to the end user. So they need to prove to their customers that the technology works. So we then built these reporting frameworks that they can reuse easily and by building data pipelines. What types of security robots might there be? So I'm pretty sure everybody has seen some type of a robot. So you have mobile surveillance robot. These are on wheels mostly. You have drones which fly, and then you have leg platforms, which are basically your dog robots, and more recently what are called humanoids as well. So when and where can they be used? So I have a few videos and pictures here. The first one here is the outdoor drone. The outdoor drone can be used to cover a vast number of areas. Again, the brain, which is the video analytics, is trying to solve some specific problems because it's now needs to solve high resolution pictures, very small objects, things like that, right? So it can do rooftop checks, inspection and things like that. However, the problem with outdoor drone is now you have to work with regulations. In Singapore, I heard something like 95% of the airspace you can't fly drones anymore. So things like that start to happen. So it's kind of become limited, right? What has become more interesting, at least for us, is the concept of tethered drones. So what if we mount a tethered drone on a moving robot? Maybe now it's becoming more useful because tethered drones are not regulated. Not yet, at least. Maybe after this talk. Indoor drones. Indoor drones are primarily used, as you can see, inside office spaces and things like that. But it can't specifically work when there are people working and there is public involved. It's used for very specific use cases as well, such as warehouse security management, where is less number of people to be assumed. Office space surveillance, it works because after 6 p.m., let's say there is not a lot of people there, then it can actually do the job. Then you have the robot dogs. We actually get a lot of questions about why not dogs. So which is why we decided to include this as well. So it can, the flexibility of the traversability for where the dogs can go is what its biggest strength is. However, for the kind of patrols that our customers want to do, the battery capacity and the payload capacity is not that great, at least not for the kind of things that we want to do. So we haven't started looking into the dogs yet. It doesn't mean that we might not do it in the future. It's just that our core market is not there yet. But it has been used a lot in facilities inspection. I've also seen it being used in power plant inspection, offshore marine inspection, and those kinds of things as well. So that's where we decided when KABAM started to look at wheeled robots for security. And so you have these two robots here. One is called Colab, which is the white taller one, and the other one is called Halo. Colab is an indoor security robot and Halo is an outdoor security robot. Both of them come with 360 degrees camera view so that you will be able to see what's happening on all fronts. And all of them come equipped with video analytics that we develop in-house as well. Now, why do we need two different types of form factors? It's mostly for the traversability. For the indoor robots, even from the design, our customers want it to be a little bit more, let's say, hidden in the background, so to speak. It's just silently doing its job and not causing a lot of attention to itself. So it's supposed to look like basically a Xerox machine. That's what. So the outdoor robot model Halo is supposed to look a little bit more imposing because it's doing more things like perimeter patrol, act as an actual deterrence, and make sure that people are not entering through fences and things like that. And it has a 4-wheel platform, which makes it more rugged to traverse off-road and stuff. Okay, now you have the platform, you have the physical thing, what's happening behind the robot, what kind of video analytics do we support. These are just a few. We don't deploy all of these video analytics for every customer. It's on a case-by-case basis. But we look for things like people crowding. We look for vehicle detection, which is a very interesting use case. Why a security robot needs to detect vehicles. We have at least a few different sites in Singapore where we are using a robot to do something called a drop-off patrol. I'm sure some of you might have heard me talking about this before, but what happens is that with all these ride-sharing companies, there is a lot more drivers on the road. And in the drop-off areas, especially during peak office hours, either during starting or ending, you have a lot of these cars lining up and causing congestion. Some of them park illegally for a really long time, go in to grab their pickup orders and come back, and which they are not supposed to do, which is causing congestion. So usually what happens is in a big mall or even a residential complex or office area, there is a single security guard who's sitting for an 8-hour shift just doing this. which I'm not sure if it's the best use of a human intelligence. So what we are saying is that instead of a human doing this, let the human do something that deserves a little bit more thinking. So in this case, we are able to automate this entire workflow of drop-off patrolling using a robot for that 8-hour shift. So what we are trying to say here is, I'll talk about this in a second, we are not here to replace the human security guard's intelligence. We are here to replace what they're trying to do, which is a lot more monotonous, and bring a lot more dynamism to the job which requires humans. Now, these are what I would call traditional machine learning models or computer vision based techniques to do these kinds of things. With the advent of LLMs and VLMs, we are able to do more. I'm not expecting you all to read what's here. It's pretty small, so I will just give you a gist for what this says. So what we're trying to do is, there is a picture, and we are basically asking a VLM model, what do you see in this picture? And it says, I've seen an image that appears to be from a night vision or an infrared camera. It talks about the pattern of dots. It talks about the ceiling featuring exposed beams. It also says that there is a text called IP camera indicating the type of camera used, and also picks up the timestamp. Right? So this is a game changer, at least for us in the security space, because what is a threat is something that is quite specific to a site. Sometimes our customers say, they want to detect sometimes even safety hazards, such as putting water bottles on top of treadmills, right? Something really specific like that. But others want to detect spills. Others want to detect open doors, unattended luggages, bags, and things like that as well. So the development time for collecting data and training these kinds of models for very specific use cases is obviously dependent on what kind of data is available, right? But with this kind of general purpose models, we can get to at least the POC stage much faster with our customers and start deploying things while we get the customers agreement to do site-specific data collection to allow for more scalable models to be deployed based on top of this data. So what we are saying is, use these kinds of VLM models for data annotation, and then you can fine-tune your own narrow models for specific sites purposes. Another example, this is a picture of the robot's back camera facing a pillar, where we have a sticker that says 24-hour video surveillance something, right? And the system is able to pick this up. And then it says the sign informs about 24-hour video surveillance and requests that individual do not touch the robot. Robot has also not noted indications or visual evidence of an abandoned luggage or bag present, because we asked the prompt whether it sees something, right? So what we are doing here is trying to bring security operations more to the human and very specific to sites, and not be bogged down by what current models and the development timelines that are we are bound to when we are training traditional models. Can you move your boom down and go to the entrance? So this is another power of using LLM. So we built this interface again based on ChatGPT API. I don't claim that we have developed the LLM itself, but what we built is an action engine which is giving the LLM agent some powers to make the robot do certain things. So I gave it a particularly complex command to say, this particular robot has a boom that can raise up the camera. So I asked it to move the boom down and then go to the entrance, and it's able to do that and generate the instructions automatically.
I have moved the boom down and I'm now at the entrance.
So what we imagine is this human-robot interaction is going to become quite interesting based on these LLMs. Okay, so those are all kind of theoretical and what could be, right? And how are we actually using it in real world? So here is a use case of our Colab being deployed. Remember I said Colab is an indoor robot. This particularly doesn't look indoor, but that's what our sales team does, right? But here we can see that it's more of a near door kind of an environment. The good thing is, at least in Singapore, most of these are sheltered. So even if it rains outside, it's okay for an indoor robot to patrol in these kinds of areas. So what we do is we do something called a site survey. We map out the flow plan. We look at checkpoints and specific detections to do at specific areas based on the customer's request. And then we plan out the patrol path for them. And here we have detection of people lying down, people smoking, and stuff like that. This is an outdoor use case where a Halo is deployed at the Bay East Gardens. Basically, this is Gardens by the Bay Flower Dome. From there, you can see the robot on the other side, which is doing daily patrols for detecting unattended bags. People leave after doing picnics and things like that, and loitering people, which is basically we stand there and see if somebody is just waiting there for more than 5 minutes or something like that. Let the security guard know that something's happening. The robot also has built-in action, so once it detects something, it can also say something to act as a deterrence as well. So based on these use cases and some of the things that I talked about in terms of like drop-off patrol use case, this is what we imagine. We are not trying to replace all the things that the security officer is doing. There are different parts of the pie that the robot can do right now. So let's use the robots to automate that and then use the security guard to do a lot more high-level task management. So imagine the guard has not just CCTV cameras now, but also robots that can move around, robots to respond to things as well. So becomes more of a high-level manager of this fleet of robots and cameras and other devices rather than just cameras. Now, one other thing that we look at KABAM is the robots are only useful when they are integrated into operations as well as infrastructure. And the way we do that is using our Smart Plus application. This is an application that we have developed for remote robot management. So you can connect to a robot securely from anywhere in the world, wherever you are and wherever the robot is over the internet. All of our robots come built in with 4G capability, and you just need a 4G SIM card, insert in, and then you'll be able to see the robot online. What this additionally does is also it can help you connect to infrastructure such as lifts, doors, and these kinds of things. So the more area that the robot covers, it's actually directly transferable to ROI for our customers. So the more levels it operates at as well. And so here you see some videos where how our operators create missions for the robots. So these are not engineers. We train technicians to do this. We also train security guards to do this. It's just point and click. You click and then the robot can go. You can also see the real-time view for what this looks like on the web page itself. And so when we talk about integration, we talk about various levels. So what we imagine is that the robot is not just doing patrols in its own isolation, but working in an entire ecosystem. What does that mean? Can my CCTV camera detect some kind of a detection, let's say an intruder detection? So CCTV cameras have static lines, and if somebody crosses the line, it detects something, right? Once that happens, instead of sending a security guard, can I send a robot there automatically? So these are the kinds of orchestrations that we are currently working with where these kinds of things will help. Lifts and access control, so we work with different kinds of vendors. That's the vendors like Kony, Otis, etc. This is where we wanted to reuse some of the good stuff that was done with the RMF team. to build fleet adapters for these kinds of devices. We are also building fleet adapters for other kinds of robots as well to enable them to be RMF enabled, basically. So we have a robot in People's Park Complex now taking lifts every day using this framework. We are also working on a project with our friends at LionSpot to deploy the same infrastructure for the LionSpot to take Kony lifts at schools with MOE project as well. This is, I asked them to change placeholder. It's not a placeholder. But this is something new that we are announcing today. We are working with Megazo. Frankie, if you're here, maybe he's busy. So Megazo is a company who do retrofitting of existing doors to make them automated. So one of the big parts of working with infrastructure teams is you don't want to go to a building and say, change your doors to auto doors, change your lifts to API capable. So what we want is a system that can work with older level of lifts and doors as well. So Megazo provides this kind of hardware and software control. So now with these APIs, KABAM has worked on developing a fleet adapter. So that's the link to the GitHub repo. We have a demonstration of this at our booth. So go talk to Gary and team, and they can talk more about this. And it shows the RMF dashboard. And we've shown the adapter to work with two different types of robots. So you have Colab and LionSpot taking the lifts. So all in all, we think the future is here, and we are embracing the future, like Ms. Mirella was saying from AWS. And we think security can become better. We think security can be more human-centric. So the way we do this is using robots, right? So physical presence. We have advanced video analytics functions. We are also looking into VLMs and LLMs to improve the adoption of robots, because remember that these security guards are from the in their late 50s. So we need to make it easy for them to adopt technology. So we think human-robot interaction is a way to solve that problem. And then finally being reactive instead of proactive. And the way we do that is by integrating to other types of sensors and cameras and alerts that are available in the ecosystem, so that you can use the robot to be commanded to the site where it needs to go to as well. So that's, I think, yeah, so you can follow us on LinkedIn. And yeah, if you have any questions, you can come back to our booth and we'll be happy to chat. Thanks for listening.